Hey guys, so today I'm going to show you how to make a crown splash like this. It's actually far simpler than you think, and we're going to create it from scratch. It's far simpler than what I originally thought too. And so yeah, we're going to create it from scratch. I originally did it in a rebel way where I took a fractured sphere and split out the parts and um, everything like that. Turns out it's so much easier just to do it the way I'm going to describe. And so, yeah, let's get right into it. I'm going to start from ground zero. So I'm going to use this as my guide. Going to make a new sphere. And right away, I don't like the way this is meshed. So I'm going to turn this into a polygon. This is just so it's more evenly distributed. And we're going to see our grid here. And I'm going to do match size to make it sit on the ground plane. I'm going to squash it a bit. Let's go back into auto. I'm going to squash it and let's just space it out a bit. So we want it pretty flat, and then we're going to have it quite out there. And we want both of these sides to be equal in X and Z. And that's just so it makes the next calculation a lot easier. So next we need actual points in the inside. So the way I'm going to do that is just with a points from volume. So points from volume. And we can see that it fills our sphere with points, and we're just going to jitter it out a little bit. Next thing is let's just set up our flip just so we can go and take care of that. And wait on .network. And this is going to be our flip container. So flip. Gonna go inside, nothing's in there. We're gonna do flip object, flip solver, and then we're gonna source with our pop source. And this is just maximizing flexibility. We're gonna do a gravity here. We're gonna merge our ground plane because we are gonna collide with the ground plane. Then we're gonna hide it so we can't see it. Gonna put this in here. We're gonna get rid of this. We don't want that. We want to switch it to particle just because, I don't know, it's just what I like doing. Guides, particles, change that to particles so that we see it as actual particles. Our source is going to be this pop source. We're just going to source for all the points, the first input, all on one frame. The way I'm going to do that, there's a few ways to do it. You could just say $FF or $F equals 1, meaning if your starting frame is 1, then make it 1. This is a Boolean value. Otherwise, make it 0. So you can see here it's 0. It's 1, and then it's 0 when we go to frame 2. We don't want that, or we can do that, but the easier way is actually just starting frame or simulation frame. So if the simulation frame is frame 1, then go to this. Now, it's not technically working, and this is why I don't like the guide, because it deceives you. The reason for that is because your flip object actually needs to have solve on creation frame turned on, and now you can see all your flip particles are actually existing in flip space. So these two ways work the same way, but we're just going to do $SF just because it makes it a lot simpler. So you can use this on any frame. Like if we were to change the starting frame here to say 20, this would still work. It would just work on frame 20. So that's why I like that method, because this guy is what determines when it starts. So we have our basic flip started, and I'm just going to say flip star here, just so we're not merging in that ground plane. And we have our basic, super basic flip stem, but we are making progress. And let's continue. So the next step is I'm going to tie my point separation from flip into my points from volume so that it's 1-to-1 and I can really see what's changing. I'm going to pin my viewport here so I can really dial this in. And then once that's dialed in, which it looks good now, I'm gonna visualize the velocities. So the way I'm gonna do that is with the pop bop. I'm gonna take this, do length. We're gonna get the length of the velocity, which is the magnitude. We're gonna fit that from 0 to whatever we determine, and that's going to fit it down into 0 to 1. And we need a 0 to 1 for the ramp parameter. This takes in a 0 to 1 value and spits out another 0 to 1 value, but it's converting it into a color. So here we're going to just put color, and we're going to plug that. You don't have to, but that's just what I want to call it. A over to make your stuff flow like that. And then I'm going to change these colors here. So blue, light blue, and then let's get a good value for our max. Something like that might work. Cool. We're heading still in the right direction, so that's good. I'm going to raise this up a little bit. Don't want it too far up just yet. And then regarding the actual ground splash, let's get to that. So what you need for the ground splash, whatever, is we need a way to tell it only work on the edges. So only put velocity around the edges. We need some kind of fall off. The easiest way to do that is just with because it's at origin, because it's at 0, 0 space, we can simply do, well, there's actually a few ways we can do this, but the simplest way is just to take, we're gonna call that float attribute F, just because I use F a lot, just when I'm testing things or even just one-offs or masks. So I'm gonna say F is, and we can just use that length again, but we're just gonna take the length of P. And you'll see that when we turn this on, I already have this set up. If you don't have it set up, you can go here, just click the F in this attribute wrangle, and then I'll set that up for you. So you can see it's perfectly centered, perfectly like a target, and you'll see the edges are perfect. Now, this isn't quite what we want. We want the fall off. We want to be able to control the fall off a lot better. So we can't just say F. We need to actually fit this. So the length of P is going to be it's going to be 0 to 1.5. So we need a way to fit this to 0 to 1 so we can control it better. So I'm going to fit this, comma, 0, sorry. So the minimum is 0, yeah. The maximum is whatever we tell it. And then we want to fit that into 0 to 1. So I hope that makes sense. Don't worry if it doesn't, but we're basically just doing that. And we're fitting that into this 0 to 1. So this outputs, this whole thing is making F a 0 to 1 value. We've just stretched it out so that we're getting the edges, because it should be 1.4, because that's what we've told this. So we technically could actually just take the radius, and if you wanted to, and bind it here, and that way everything's procedural. And what I want to do is actually put this into a ramp, because I want to really have control over it. So we're gonna just take F again, just say F ramp, and we're gonna feed in F as our attribute for control. Make sure you do that, and this looks exactly the same as before. And you can see here, nothing's changed, and that's because it's set to linear, so 0 to 1. And I like B-spline. Is it B-spline? I think that's B-spline. Yeah. So you can see here, ooh, it's changing. So we want to make it so that only, you can see here kind of what it's doing. Like that means the outer edge is super strong, and then it tapers off in a very smooth, curved, exponential manner down to 0 based on, and you can even pull this in to get an even like stronger effect. But I like this for now. Let's just see what that does. So we have this fall off. And again, there's a few different ways of doing it, but this is one way. We have this fall off, and that's wonderful. Now we're going to take, this is going to be our fall off. So we're already like most of the way there. Now all we have to do is set up our velocities. So to set up the velocity, what we're going to do is we need a way to, what is a crown splash? Crown splash goes up and outside. So it goes up in space and it goes outside of the circle. So we need a way to tell it to move away from the circle and up. And we want to be able to control those both independently. So what I'm going to do is just in another wrangle, I'm going to say v at v plus equals, meaning it's the same thing as saying v at v plus. It's just a shorthand. So we're going to say v at v, let me start over, plus equals, and I'm going to do a set, and in here I'm going to do this, and this is just so that, because we know we want it to go up, but we just want to determine how much. And now when we do this, everything is going to go up exactly at the same rate and everything. Now we want to be able to control it. Now we're going to control it a little bit later, but for right now, so this is going up, so let's label this up. And then here we're going to say outside. Outward's actually a much better. So the way we're going to do that is actually just v at v plus equals. And we want to get the center of the sphere. So let me go back in here. Well, it's erroring out because we didn't complete the expression. So we're going to say v at v plus equals. We're going to get bounding box center. So this is going to it's going to return a vector. So it returns the center of the bounding box for this geometry. Because it's exactly at 0, we're just going to say v at v. We're going to get the center of this sphere. So it's basically, let's see, it's basically going to create a point directly in the center. So it's just like saying, and because our sphere is, well, technically our sphere is up here, but if our sphere was right here, it would be just like adding a sphere right here in the middle, like this point here in space, which is 0, 0, 0. So it's just like that, grabbing that position if the sphere was here. But because it's here, it's lifted up a little bit, it's going to grab this center position. So the center of this sphere here. Hope that makes sense. So it's just grabbing that. And then we want to subtract that. Let me make sure this is correct. So the way that vectors, velocities work when you're subtracting is it's to from. So we're saying from, if we want an hour, we want to say from P to the, or sorry, from the center point to the P. So from here to here. So are we doing that right? So from here to here. So from no, this needs to be flipped. Because it's 2, we want to go to P and from get bounding box center. From get bounding box center. I have to wrap my head around because it's backwards. When you subtract, it's backwards. It's a little bit, honestly, it's a little bit confusing for me. But I always get it, just a matter of time. So we're adding that, and then we want to be able to take this and multiply the outward amount. So we're going to put it in parentheses just so we have more control, and then we're going to say outward velocity. And we're going to make that, and then now you can see everything. You can see it working an amount, but then I want to have these finer controls like 0 to 1, and then I'm going to boost it later, and we can just do that. Velocity boost, multiplier, and we're gonna go in here. Oh shoot, oh wait, no, that should work. 220. Now we want to multiply everything by f, by that mask, and that's the magic. So once we've done that, you get your crown splash. Let's cut that visualizer off. Now there's not nearly as many points as we need. Okay, that looks much better, but we still have some missing components. What we need is we want a way to randomize this. There's a few things we need to do. There's a length multiply noise, and what this is gonna do is it's gonna multiply. We can actually show you here. Okay, I'm just gonna do it. I know it works, so yeah, you can see here it is working. I'm not sure honestly why it's breaking, because this usually works. Like right when you put it in, usually works. I'm not quite sure. But yeah, you just wanna, and we're doing length only, which means it's just gonna multiply all those velocities by from 0 to, what is this, 1? We'll just say 1 in a noisy way. And actually, I'm gonna cut the cache off so we can live update this. So we can make this 0.2, see what that looks like. 0.7 looks kind of cool, but let's do more like 0.5, 0.35. And what we really need also is we need more particles to fill up the holes. The easiest way to do that is just in the, well, there's surface tension that we can play with. You can see right away with what that's doing. And yeah, whenever, oh, let's cut the volume limits off so that when we center, it'll work. And yeah, you just play with this to really like dial in. You can cut that cache off. It's really great for live seeing what's going on. And the magic is gonna be in the reseeding. Surface oversampling. Let's turn that to 2. See what happens. More like 5. And let's also crank up the number of points. Yeah, that looks much better. And then this, let's make this like 0.5. And then we can do like that. Well, that's kind of cool. Again, I don't understand why this isn't quite working. Yeah, it looks kind of cool. Maybe the surface tension is a little too much. No, you definitely want that on. Let's make it 5, perhaps. looks cool. And if you wanted the crown splash to be less, now you can cache it. You can when you do your final sim, you'll want to lower this to like 50 so that it's not consuming too much RAM, because Windows does actually have a memory leak. And that's basically it. And you'll just crank this up. Just wanted to quickly show you how to do a crown splash. These are like very basic, and I just wanted to show you quickly how you can like very quickly do something like this. And again, you can if you wanted these to be separated, I actually think that might be a cool idea, so that you're not, so you have individual control over each one. Let's do that. So we're gonna have up, and here I'm just gonna get rid of these two, and then outward. And the reason for this, so we have our up, and we have our this way, and this is why I wanted to show you this, is so that we could take the length, multiply it by noise, and have individual control over each and every section. And now what you can do is you have that fall off, you have the up, you have the sideways, and now you can just add all these together. So now you can say, okay, VIV plus equals up input 1V, and then VIV plus equals up input. And you have to make sure this is lowercase. I actually got messed up in recently. You have to make sure that these are lowercase. And I hope that works. Yeah, it looks very different now. Let's see. Yeah, so now you're getting like, you're able to really control that. And we could even do like 0.6. I mean, you can really control this and get really cool looking results. And so we have this outward. Let's get rid of these. We don't want that. We do want that. There we go. And that way you have really high amount of control over exactly how your crown splash looks. And again, the real magic here, let's go to frame 10 just so it's not so much, is going to be this surface oversampling. This is super important to making sure you fill up those holes. You can go like 10 particles per voxel as well. And yeah, just wanted to show you like really quickly how you can go about doing super simple crown splash like this, and to help you with your workflow. Super straightforward, super easy. Just wanted to show you guys. All right, take it easy. Hey, like and subscribe to the video, to my channel. I mean, like the video, subscribe to my channel if you found this helpful at all, and I will see you guys soon. All right, bye.